So what I want to talk about last is an application problem, and this is in your notes, and what we have is, it says the number of n of bacteria in a refrigerated food is given by this function up here. Now this is just a restriction because the temperature is varied. So this is the only temperatures it works for it, because it says where T is the temperature of the food in degrees Celsius. So these are your temperatures to work with. Okay, so those are your temperatures. It says when the food is removed from refrigeration, the temperature of the food is given by this function, where T is the time in hours. Okay, so it's removed from the refrigerator, and this is the new temperature, still in degrees Celsius. It says for problem A, write the composition and interpret its meaning in context. So we have this outside function here, and I'm going to write this up here because I'm going to run out of room. 20 times t, so I'm going to plug in t of t squared minus 80 t of t plus 500. So now I'm going to plug in what this function is. So 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. So what we have here is a function where we can simplify everything. We have to deal with exponents first. So if I multiply this all out, I get 20. 4t, if I multiply this all out, I get 16t squared plus 16t plus 4 minus, if I'm going to multiply these two things together, I can, 320t minus 160 plus 500. Go a little bit further, multiply these out, 320t squared plus 320 plus 80 minus 320t minus 160 plus 500. So combining like terms, notice we have this should have a t here. We have two 320t's that are canceled. We have an 80, 580 minus 160. That's going to be 420, I believe. And we have 320 t squared plus 420. So this is my new function. So we have to ask ourselves, what are we plugging in? This lowercase t, and what are we getting back? Well, this n stands for bacteria. So this n stands for what bacteria we're going to get. T stands for time. So after t hours, how many bacteria is on the food? So we're talking about time and bacteria because the n deals with bacteria. This lowercase t deals with time. So it says then find the time when the bacteria count reaches 2,000. So we have this equation. We have the bacteria, or n of t. We want that equaling 2,000. So what we need to do is we need to set that equation here and set it equal to 2,000. So 2,000 equals 320 t squared plus 420. So I'm going to subtract 420, and I get 1,580 equals 320 t squared. So what I have left then is I have to divide by 320, and I'm not sure what that is off the top of my head, So if I take 1580 and divide it by 320, I get 4.9375, and that's t squared. So I'm not done yet, so I need to take the square root of that. So I take the square root of that to get what my final answer is. My final answer is approximately 2.22 hours. So after 2.22 hours approximately, there is a bacteria count of 2,000.